fundamental theorem on differentiation. So the first term is this one. The differential for constant function is 0. That is, the derivatives of a constant number is equal to 0. So for this one, you take fx is equal to c. Then what is f of x plus h? Also it will be c, because this function does not depend on x. So f prime of x, by definition, it is limit h tend to 0, f of x plus h minus f of x by h, and this is equal to limit h tend to 0. You replace the value of this one by c and this also by c. So this c minus c by h, which is equal to limit h tend to 0. 0 by h will be 0. So that's why the derivative of constant number is 0. Now next, the derivative of a product of a constant number and a function of x will be constant number into the derivative of that function. So take fx is equal to c phi of x. Then what is f of x plus h? It will be c times of phi of x plus h. Replace x by x plus h. Then next, using the definition of derivative, f prime of x is equal to limit h tend to 0, f of x plus h minus fx by h. Replace the value of this one by this and the value of fx by this. And from here you see that c is a term or a number which is common to this. Then, and since it does not depend on h, so therefore you can take it outside the limit. So it will be c times of limit h tend to 0, phi of x plus h minus phi x by h. And by definition of derivative on phi x, this is same as phi prime of x. So it will be phi f prime of x, or the derivative of c phi x is equal to c times phi prime of x. Now let us come to the third fundamental theorem on differentiation. It is ddx of phi x plus or minus chi of x. It will be the sum of their derivatives or the difference of their derivatives. So let me take the case of the sum of two functions. So consider fx to be phi x plus chi x. Then fx plus h is equal to phi of x plus h plus chi of x plus h. So f prime of x will be the derivative of phi x plus chi x, and by definition it is limit h tend to 0, fx plus h minus f of x. But what is f of x plus h? It is phi of x plus h plus chi of x plus h, minus what is fx? It is phi x plus chi of x whole thing divided by h. And this one you can write it as limit h tend to 0. Combine this one and this. So it will be phi of x plus h minus phi of x, the denominator being h, then plus limit h tend to 0, chi of x plus h minus chi of x divided by h. And this is equal to phi prime of x plus chi prime of x. So therefore the derivative of phi x plus chi x will be the sum of their derivative, phi prime of x plus chi prime of x. Similarly, if you replace plus by minus, it will be the same only. Now let me come to the next one, that is the derivative of the product of two functions. Phi x into chi x will be phi of x into chi prime of x plus chi x into phi prime of x. So here you take fx to be the product of these two functions. Fx plus h, replace x by x plus h. That by definition, what is f prime of x? It is limit h tend to 0, fx plus h minus fx by h. So this is equal to limit h tend to 0. Substitute this one. It will be h into chi of x plus h minus phi x into chi of x whole thing divided by h. Now next, what we can do now, this implies that f prime of x is equal to limit h tend to 0. You add and subtract by this term, so it will be phi of x plus h chi of x plus h minus, add and subtract with this term, so it will be phi of x plus h chi x plus phi of x plus h chi of x minus that term phi x chi x, phi x chi x. Okay, so whole thing divided by h. So you add and subtract this term, minus this plus this, so this will be cancelled, so it remained only this term, this one and this, divided by h, which is the original one. So now here you can write this one as limit h tend to 0. If you combine these two, you can see that phi of x plus h is common. So into chi of x plus h minus shy of x divided by h. Plus now from here you see that shy of x is common. You combine this last two, it will be limit h tend to 0. Shy of x you take it out and then into phi of x plus h minus phi of x whole thing divided by h. So this is equal to limit h tends to 0 phi of x plus h into limit h tends to 0 shy of x plus h minus shy of x divided by h plus now this one. It is now you can see from here that shy x does not depend on h, so you can take it outside the limit shy of x into limit h tend to 0 phi of x plus h minus phi of x divided by h. Now I can, why I apply this property, limit of this one into this is same as limit h tend to 0 of the first function into limit h tend to 0 of this one. From the theorem on limits of a function, limit x tends to a fx into g of x is equal to limit x tends to a f of x into limit x tends to a g of x. So by applying this property, I can express this one as the product of their limit. And here I'm taking shy x outside. Why? Because it does not depend on h. So you can apply now the limit of what is this? It will be phi of x as h tend to 0. And this one is equal to the derivative by definition. So of shy prime of x plus shy of x into this one is the derivative of phi of x, phi prime of x. So this implies that the derivative of the product of two functions phi x into shy x is equal to phi x. This implies that the product of the derivative of phi x into shy x is equal to phi x into shy prime of x plus shy x into phi prime of x. Here you can see that I'm applying this result here. Limit x tends to fx into gx is limit x tends to fx into limit x tends to a gx. So this one, when you take the limit of this one as h tend to 0, it will give you phi of x. And this one is by definition of derivative, it is shy prime of x. And for the second part, shy x, I'm taking outside the limit because it does not depend on h, then into limit of that second part. So the second term. So and the limit of the second term is nothing but it is the derivative of phi of x. So it will be phi prime of x. So finally we are getting the derivative of the product as phi x into shy prime of x plus shy x into phi prime of x. And lastly, let us come to this one, the fifth fundamental theorem on differentiation. It is the ddx, the derivative of the quotient of two functions phi x by shy x. This will exist provided the value of shy x is not equal to, provided shy x is not equal to 0. So the formula for this one, it will be phi prime of x into shy of x minus shy prime of x into phi x by shy x the whole square. So here we can take fx to be phi x by shy x. Then what is f of x plus h? It will be phi of x plus h by shy of x plus h. Replace x by x plus h. By definition, f prime of x is equal to limit h tend to 0 fx plus h minus f of x by h. And this is equal to phi x plus h by shy x plus h minus phi x by shy x upon h. So it is limit h tend to 0 1 by h into this one. Take the LCM. It will be shy x into phi of x plus h minus phi x into shy of x plus h. The numerator will be this one now. Divided by the denominator, it will be the product of these two. So here what you need to do is add this term. Phi of x plus h, shy of x will remain as it is. So you add this term minus shy x phi x plus shy x phi x minus this one phi x into shy of x plus h whole x plus h whole thing divided by shy of x plus h into shy of x. So this is equal to limit h tends to 0. I can take this one as 1 by shy of x plus h into shy of x. Then I can bring back this denominator inside. So here what I can do, I can combine these two. Shy x is common here, so it will be shy x into phi of x plus h minus phi of x divided by h minus, then here I can take out phi of x common into, now here it is plus, here it is minus, so when I take out minus phi x, so this one will be psi of x plus h minus this phi of x. This whole thing divided by h. Okay, I'll just show you in the next step. So this implies that f prime of x is equal to limit h tends to 0, 1 by psi of x plus h into psi of x. So the term here will become psi of x into phi of x plus h minus phi of x divided by h minus phi of x into psi of x plus h minus psi of x divided by h. So here you can apply the limit. It will be limit h tends to 0, 1 by psi of x plus h into limit into 1 by that psi of x will remain as it is into limit h tends to 0 again. It will be, now here in this first term you see that psi x does not depend on h, so you can take it outside, so psi of x here into limit h tend to 0, phi of x plus h minus phi of x divided by h minus, again here this one does not depend on h, so you take it as phi of x into limit h tend to 0, psi of x plus h minus psi of x divided by h. Here we can apply that property of limits of function. Limit x tends to a, fx gx is equal to limit x tends to a, fx into limit x tends to a g of x. So by applying this property, I'm getting this thing. And also you can apply this one, limit x tends to a, fx minus g of x is same as limit x tends to a, fx minus limit x tends to a g of x. So now you can see that this one is nothing but it is phi prime of x and this is psi prime of x. So finally it is limit h tend to 0, 1 by psi of x plus h psi x into this one psi x phi prime of x minus this one is phi x into psi prime of x. The denominator is this one. So as h tend to 0, so this psi of x plus h will tends to psi of x. So here we'll have psi x into psi x. So it is psi x phi prime of x in the numerator minus phi x into psi prime of x whole thing divided by psi x the whole square. So this gives you the derivative of the quotient of two function phi x by psi x, where provided that psi of x is not equal to 0.